All right, welcome everyone to today's presentation of DBA Fundamentals. Today is Query Store on-prem and in the cloud with Deepthi Goguri. Today is January 18th, 2022. In the top right-hand corner of the screen, you'll see the three leaders of the DBA Fundamentals group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If you ever have a need to reach out to us on Twitter, there are our handles. Below that are our many social media accounts and ways to get hold of us. First up on the list is Meetup. If you are not aware of the fact that we are on Meetup, please reach out to us through there and many of the other Microsoft Azure groups that are on there. They're all really great groups, and obviously we're proud to be part of that group as well. Below that is our website, dbafund.org. Please go out there today, get on that, look through that and see what different kinds of things you can see on there, because there are all kinds of our past presentations as well as our future meetings are listed on there as well. Below that, you'll see dbafundtube.com. That's our link on YouTube that has all of the goodness for our past presentations. Also, be sure to click on the link to subscribe to our channel so that you'll be aware when we actually put our next presentation out there. Below that is Twitter. We are on there at DBA Fund. Also, we're available on Slack and on LinkedIn. We post every now and again on those as well, and there is a conversation going for some time. All right. As always, this session is being recorded and usually is available within 1 to 2 days. Check it out on dbafundtube.com, and then you'll actually get when the latest version is posted on there. Also, everyone be sure to actually turn your cameras off and to have yourself on mute since we are recording, unless you just want to hear yourself talking about whatever, as some people have been known to do in the past. With that, we go to today's presentation from Deepthi. Deepthi, all yours.
Kevin. Let me share my screen. Are you able to see my presentation?
Yes, we see PowerPoint.
Yeah. Can you let me know once you mute? I mean, I can hear my voice again.
There you go.
Okay. Now it's perfect. Thank you so much, Kevin. Hello, everyone. Thank you so much for taking your time for attending this session today. Thank you so much, Kevin, Steve, and Shan, for giving me this wonderful opportunity to speak for DBA Fundamentals User Group. It's an honor to be here. So today, we are going to learn about Query Store on-prem and in the cloud. So if you're not familiar with Query Store, or if you wanted to just brush up your skills on Query Store, this session is right for you. There are a lot of demos. So we will be spending a couple of minutes first covering all the slides, what the Query Store is about and all. And then later we are going to see the demo in detail. A little bit about me. I'm a database administrator having 7 years of experience in managing SQL Server and databases. I'm a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology at Eastern Illinois University here in Chicago. And I'm an organizer for a couple of user groups for Diversity, Equity, and Inclusion user group and Microsoft Data and AI South Florida user group. And also I do volunteering for Women in Technology user group as well. Apart from my work and my community work, I love arts and crafts. It gives me so much peace, making things with my own hands. If you would like to contact me on Twitter, DBA Nuggets is my user ID, and I'm very active on LinkedIn as well. You can contact me there, and I usually blog about SQL Server stuff. At dbanuggets.com is my website. Recently I'm blogging more about Query Store. So if you'd like to go and look into the extension of this presentation, please look into my website. So what are we going to cover in this session? We are going to see the introduction of Query Store benefits. As one of the benefits of Query Store is plan forcing. So once you force a plan, there might be certain failures that might be caused. It's like once you force a plan, you cannot forget it, especially when you are manually forcing it. There might be certain reasons of failures. So how to capture those failures, the query store failures? Again, the query itself doesn't fail, but the reason why the optimizer did not choose the force plan will be captured. We are going to look into how to see those failures and how to avoid them. And also we are going to see the automatic plan correction, which is available in Enterprise Edition of SQL Server from 2017 and above. And we are also going to talk about the preview feature, which is Query Store hints. So let's talk about the introduction of Query Store. Query Store is a feature that got introduced in 2016. So basically, you need to go ahead and enable it on the database level. So once you have the SQL Server, it's not enabled by default. It's a database level feature. You need to go ahead and manually enable it. So once you enable it on a database, it will go ahead and capture all of the queries and the execution stats on it, like the query ID, query text, execution plan information, along with all the resource consumption information. So what is the use of this, right? Once we capture that, if you have queries like creating multiple execution plans, we always have those queries, right? You can go ahead and compare the execution plans, difference between the execution plans side by side, see how much resource consumption they both are using. And if you think one plan is optimal, but it is using the non-optimal plan, you can manually go ahead and force the plan which you think is optimal. So the next time you run the same query, again, like let's say store procedure, no matter what parameter you use, it will go ahead and use the force plan that you forced. So that is one of the benefits of the query store. You can fix the problem very easy before permanently solving the problem by talking to your developer and working with them to tune the code itself to solve the problem permanently. Query store feature will provide you that nice feature of going ahead and quickly solving the problem. And it is disabled by default on SQL Server if you have, and it is also disabled by default on Azure Synapse Analytical Database. But if you have Azure SQL Database, it is enabled by default and you cannot turn it off. And you cannot enable this on system databases like master or tempdb database. This is the interesting part, how Query Store actually works. This screen, like, it looks like overwhelming, but let me explain in a simple words how the Query Store actually works. Whenever a query is sent to the SQL Server, it will first go ahead and check if the query is running for the first time. If it is running for the first time, then it will go through the compilation and the optimization phases to build a new execution plan. But if it is not running for the first time, it will go ahead and check if there is already a plan in the cache. If there is no plan in the cache, it will again go through the compilation and the optimization phases to build a plan. But if the plan is already in the cache, then all right, it will go ahead and take that plan from the cache. But before moving forward, it will go ahead and check for the recompilation. So what happens during this phase, right? So basically, it will go ahead and check if the new plan that got generated or the plan that has been taken from the cache, is it similar to the force plan? Let's say you have you have a store procedure and you have forced a plan for that. So At this point, at the check for the recompilation phase, it will go ahead and check whether the plan that has been taken from the cache or generated newly is the same as the force plan. If it is not, then go ahead and apply the force plan. It will go ahead and apply it. But if it is similar to the force plan, then it will go ahead and proceed. Before moving further, before going into the execution phase, the query text and the query plan will be captured in the memory. There are certain stores in the memory for the query store. So when you enable the query store on a database, there are certain stores that will be also enabled in the memory, like plan store. So the query text and the query plan will be captured in the memory. That process happens asynchronously. And then later, the query goes to the execution phase. Once the query gets executed, the runtime stats information will be also collected into the memory in the runtime stats store. Again, this is in the memory, correct? And it is also captured into the memory asynchronously. But once the flush out intervals reaches, then all of this information that is captured in the memory will be asynchronously moved to the query store schema. So where is this query store schema? It is in the primary data file of the database. As it is a system information, right? It is stored in the primary data file and you cannot change it. This is how the query store works behind the scenes. But you might be having question, why do I have to enable query store when we already have the plan cache? Right, by default, we have plan cache. All the plans will be captured inside the plan cache. So what is the difference between both of them and what is the advantage of query store? Let's see a couple of the differences. If you have the plan cache, whenever you restart the SQL Server, these plans inside the plan cache are flushed out. But with the query store, all the data will be retained even after the SQL Server restarts. And it will be retained until it hits the cleanup policy based upon your settings. So by default, the cleanup policy is 30 days, but you can definitely go and change that defaults. And with the plan cache will only store the latest plan information, but query store will collect the query information along with the statistics information, the runtime stats, and all the other resource consumption information over time. Whenever there is a memory pressure on the SQL Server, the SQL Server will go ahead and check if there are any least recently used execution plans in the plan cache, and it will go ahead and flush out from the plan cache whenever there is a memory pressure. But with the query store, until the flush out intervals has reached, like the slide we have seen previously, all the information that is captured in the memory will be flushed out to the disk once the flush out interval has reached. And it is difficult to know why the plan has changed when you are using plan cache. But with the query store, as you capture all of the information over time, it is very easy to go ahead and troubleshoot the performance problems because you even can get the top resource consuming queries very quickly with a couple of clicks. It is very easy to identify and very quick to fix the problem. So what type of data is collected with the query store? All of the information that you are seeing here, like the query text, query ID, resource consumption information, like how much memory, IO, CPU, temp DB used, memory used, and wait stats information has been included from SQL Server 2017 and above. And as you have the history of the plans collected, you have certain tabs in the query store folder. If you wanted to know the resource consuming queries, the top resource consuming queries, you can easily go ahead and pull up the report. Like if your developer comes to your cube and asks, hey, I have some time, I need to fix the top resource consuming queries, performance tune them. Can I get the report, the top resource consuming queries? With a couple of clicks, you can provide them the report. So what are the operation modes for the query store? Once you right click on the database, go to the properties. Once you open up the properties, left side the pane, you have the query store tab. Once you open that app, you have 3 operation modes. Off, meaning it is turned off. So you have closed the doors of the query store, nothing is happening. Read only will only read the information of the first plan, but it will not write anything to the query store. But it can read the first plan information. And read write meaning it can read the force plan information at the same time write all the information that is being captured. There are also certain capture modes. So once you turn on the query store, how do you want to capture the queries, right? So you have 4 modes in here. All meaning it will capture all of the queries, even the insignificant queries that you are not looking into. Those run pretty fine and you are not bothered about them to performance tune or anything. They run pretty fast, which is not recommended. So all is not recommended by Microsoft. Auto is recommended by Microsoft and it is by default enabled from 2017 and above. So if you are in 2016, all is the default. You need to manually go ahead and change into auto. But from 2017 and above, auto is the default. So if you turn auto, it will capture the queries based upon how many times the query has run and what is the compile CPU time. We cannot we cannot we do not know how many times the query has to run and what is the limit that it have to cross for the compile CPU time. It has decided by the Microsoft, so we do not know that algorithm. When you choose none of them will be captured, and custom is where you can go ahead and customize those capture policies. Let's talk about a couple of options here. We are going to see all of the options in our demo. The cleanup policy is where all the data will be captured for 30 days by default. You can definitely go ahead and change. So once the cleanup policy has been reached, it will go ahead and delete the least recent used data, the oldest data. Data flush interval in seconds is 15 minutes by default. So all the data that is being collected in the memory will be flushed out for every 15 minutes. But sometimes whenever there is a memory pressure, right, it can flush out all the data that has been collected in the memory to disk earlier than that, than the limit being reached, like before the 15-minute interval. Maximum storage size in MB is 100 MB by default for 2016 and 2017 SQL servers and 1 GB in size from 2019. Again, for the complete list of options, please follow the Microsoft docs down below. So what are some of the benefits? As we already know, one of the benefit is plan forcing. You can easily go ahead and identify the regression that is caused by the plan changes, compare between the plans, and quickly fix the non-optimal plan usage by forcing the optimal plan. It is very quick to performance tune the queries when you do not have time to go ahead and fix the query itself. There are no changes needed to be done to the underneath code or to the application to force a plan. Personally, I use the query store. The benefit that I used by the query store is during the database upgrades. So we used for capturing the baseline information. So what I did is basically once we moved the databases, once we upgraded the databases, so we upgraded a lot of databases from 2012 to 2016 and above. So let's take an example of 2012 database migrated to 2016. Once we upgraded the database, we still have to place the database in the older compatibility mode and turn on the query store on the newer system, which is 2016 and above. Once you turn on and then capture all of the queries on the older compatibility mode of the database, so it will run and execute the execution plans just like the way it used to run on the older system, on the older compatibility mode. Later, once you capture all of the queries, then go ahead and upgrade the database to the latest compatibility mode and then run the queries. so that it can, if you have any queries that are not performing well in the newer compatibility mode, you can easily go ahead and see what the query used to run, like how it used to run, and what was the old good plan information, because you already captured that information, so that you have the ability to go ahead and force the last good plan. When I did the database upgrade, I have forced a couple of the older plans which used to run in the older compatibility mode, and I immediately fixed the problem before going ahead and see why the query is not performing well in the newer environment. It might be the cardinality estimation, right? Because cardinality estimates has changed in the newer environment of SQL Server. So there are three stores. Plan store will collect the query ID, query text, plan information. Runtime stat store will obviously collect the runtime stats information, and wait stat store will collect the wait stats information based upon categories. Let's talk a little bit about plan forcing. Plan forcing is just similar like the use plan query hint. Once you force a plan, then the next time you run the query, it will go ahead and force the forced plan information. So if there is a failure, right, as I told you, once you force a plan, there might be certain reasons why it might fail. It might not force the plan that you actually force, but it will go ahead and generate a new plan. And you might be wondering, I have actually forced the plan. Why is it going ahead and creating a new plan? So if that happens, right, the query itself doesn't fail, but the failed information will be captured within the query store. To force a plan, it is always better to do it by using the T-SQL, by using the code sp query store force plan store procedure. The advantage that you have by using the T-SQL code is, like, if you have any monitoring tools, they will capture the information of who forced what plan. But by using the graphical user interface, you might not get that information captured by using the monitoring tools. Let's talk about certain failures. Like I said, once you force a plan, the forced plan might have the objects, right, within the plan, like the indexes that are being used within the forced plan. For example, you have a store procedure, you went ahead and forced the plan, and everything is running fine. But then there is a developer who have the rights to go ahead and drop the indexes. He pulled up a report, I mean, pulled up a report of not indexes not being used recently, and this particular plan that you forced will only run on certain periods of time. So your developer went ahead and dropped the index. In that case, SQL Server will go ahead and find, I'm not able to find this force plan. So let me go ahead and do the optimization and compile phases, and let me go ahead and generate a new plan. But then, because I have chosen to create a new execution plan, let me go ahead and capture this failure information within the query store. But then I'll run the query fine. So once the index has been dropped, you can see the no index failure reason, because there is no index associated with that force plan. And there are also other reasons that might cause failures. Again, we are going to see that in our demo as well. So you can capture the failures by using two ways: by using the graphical user interface, by using queries with force plan, by using the GUI. But if you wanted to use the catalog views, just follow this query from that I captured from the Microsoft Docs. Before moving ahead, Kevin, do we have any questions? I believe there are no questions, right? Okay, let's move ahead then. So automatic plan correction. Automatic plan correction is especially for the enterprise edition of SQL Server and for the 2017 and above. So when you turn on the automatic plan correction, as the name itself says, it will automatically go ahead and monitor the plan regressions between the execution plans, and it will go ahead and automatically force the plan that it thinks is optimal, because it will compare the new plan that got generated and the old plan. It will force a plan that it thinks is optimal, and it won't stop there. It will go ahead and continuously monitor for the next created plans. Let's say the you forced the automatic plan correction forced a plan, and then a new plan got generated, but then the new plan is not running optimally. It will still keep the old good forced plan as is, and it will go ahead and continuously monitor. So it will automatically force and unforce the plan for you, so that you do not have to go ahead and continuously monitor for the plans that you forced manually, because it is so tedious task to do. As a DBA, we have several other work tasks to do, right? So if you are on enterprise edition of SQL Server, this is the best feature to go ahead and test it out. So to enable the automatic plan correction, alter database name, set automatic tuning, force last good plan to be turned on. And to know the reasons why automatic plan correction has actually chosen a different plan to force a different plan, you can you can find the information why it has chosen to force a plan by looking into this DMV sysdmdb tuning recommendations. To enable the automatic plan correction on Azure SQL database, go to the database. On the left side pane, go to the automatic tuning. It will open up a blade where you can where, which is like force plan is automatically turned on, but if you are not willing to use it, you can actually go ahead and turn it off. Let's talk a little bit about query store hints. So as an example, let's say you have a store procedure, you have a parameter sensitive, um, you have a parameter that is very sensitive, which creates a new execution plan. But all the other parameters use a different plan. But then if you wanted to make sure it runs fine, then you need to go ahead and use the recompile option within the query. So you need to basically edit the query to do that. But by using the query store hints, especially the designed a store procedure, where you can go ahead and just mention the query ID of your store procedure and then provide the hint within that store procedure, so that once you run that store procedure using the hint, right, the query store design store procedure, the next time you run the query, the store procedure with any parameter, it will go ahead and automatically sniff the um, parameter sensitiveness, and it will go ahead and design the execution plan based upon that. So it is very easy to fix the problem without changing the underlying code here. And it is available for the preview mode in Azure SQL database currently, and Elastic Pools managed instances, and for the hyperscale databases. So you can use the query store hints like max stop, recompile, maximum, minimum, grand size, compatibility level as well. So all you need is get the query ID, right? And by using the store procedure SP query store set hints, get that query ID and provide the value, like what hint you wanted to use. You can use one hint or you can use multiple hints. Enough of slides, right? Let's go ahead and see the demo now. Okay, there is. Can you hear me?
Yes.
Yes, we hear you.
Okay, thank you. So we have 30 minutes. I believe I can cover that in 30 minutes. So We are using AdventureWorks database for our demo, as well as Wide World Importers database as well. So this is my on-prem SQL Server, and I would like to go ahead and enable the AdventureWorks, alter database name, set query store to be turned on, and operation mode I wanted to put as read write so that it can read the information as well as write. Along with that, I also wanted to um, choose the options. So alter database name. All of these options we have already discussed in our slides, but the main one which we did not discuss is interval length in minutes. So the interval length in minutes is 15 minutes by default. So every 15 minutes, there will be a new interval created. Let's say we started our interval number 1. In that interval number 1, let's say a store procedure, very useful store procedure in your database. It is used very frequently, like every minute, couple of times it runs. No matter how many times the query runs within that particular interval, there will be only one row allocated for that particular query. The next time, after 15 minutes, the next interval begins, right? Again, it will only have one row. So the reason why they do not want to do that, they wanted to put that as one row, is because they do not want to blow up the query store. Size Blaze cleanup mode is auto, which is by default it is auto, but please do not turn it off, because if you turn it off, once your maximum storage limit reaches to this number, 500 MB, it will go ahead and automatically change the query store from read write to read only. But if you put it as auto, it will go ahead and clean up the data, the old data, once the size limit will be reaching 90%. So it will clean up the data until it reaches 80%, so that your query store doesn't have to go to the read-only mode. And you can choose the maximum plans per query and rest of the information that we have already discussed. Let me go ahead and enable. So we have enabled the query store. To see what all options we have enabled and what we are using, go ahead and query sys database query store options catalog view, which will show you all of the options that we have chosen: maximum storage size, threshold days, cleanup mode as auto, and rest of the information. Before going further, I would like to go ahead and just make sure I clean up the query store, alter database name, set query store clear. Do not run this in production because it will clear out all the data. And also, I would like to free up my prop cache. Now, let me go ahead and just show you by randomly running a couple of stored procedures here. I'm running 2 stored procedures, executing them, and going into the database, AdventureWorks database, expanding it. Once you enable the query store, right, it will show you this folder. Go to the top resource consuming queries, view top resource consuming queries by right clicking. So we executed 2 store procedures, and you can hover your mouse onto this graph and see what query has been executed. But then if you observe, it is parameterized. So the parameter value is not shown here. But if you would like to go ahead and see the query, go to the grid view mode, where you can see the object name and the query text information in the parameterized view. Here you have the query ID, object ID, and information, along with the plan ID information. This is the plan generated for this particular store procedure. Now, what if I go ahead and see what's there in my plan cache? So these are the stored procedures I executed and stored in the plan cache currently. If you see here, the text that is being captured here is actually the procedure itself. But here it's the parameterized view. If you see here, that's the difference. Now, 2 of the store procedure has been captured in the plan cache. Now, what will happen if I go ahead and clear out my plan cache? Will that clear out my query store? Let's see. The data inside the query store, is still persisted. Let me go ahead and clear out my query store one more time and run these ad hoc queries. So each query exactly the same with a different product IDs here, and I'm running it two times each. How does it act on ad hoc queries? I refreshed. If you see here, the same query, right? Just the parameter, the value of the product ID has changed. But as it is ad hoc, even the slightest change within the query, like comment or the space, will generate a new query ID. Will the space generate a new query ID? Let's see. I just added a slight space over here and running the same exact query with the same product ID. Let me execute that and go to the query store and refresh. If you see here, I just added a slight space and it created a new query ID. So why I am showing all this, right? If you have more and more ad hoc queries, that might blow up your query store pretty quickly because you mentioned how much space you wanted to use for the query store, right? So instead of using the ad hoc queries, lot and lot ad hoc queries, try to place the same queries within the store procedure so that you will only get one query ID for the store procedure, no matter which parameter you use. Let's put the same exact query within the store procedure and create the store procedure. I would like to clear up my procedure cache and the query store, and then run this particular store procedure twice with two different parameters and see what things are gathered here. So as we created the store procedure, it only have one query ID, but then if you observe, we executed it with two parameters. So the parameter sensitive, those are parameter sensitive, so they generated two plan IDs. But here, if you hover your mouse over here, the plan ID 2 executed in total duration 1128 milliseconds. But the old one, the plan ID 1, it went ahead and run in 5.84 milliseconds. So let's say I would like to go ahead and force this plan. Click on the plan ID 1 and then click on the force plan. But then you can go ahead and compare these both plans as well by using the compare plan here. Compare the plans. All you need to do is highlight and then go ahead and compare them by using here. You can compare the information, all the information here, the memory grant information and any indexes and cached plan size, all of the resource information here. Let me close that. But here I wanted to go ahead and force this plan ID 1. So click on the plan ID 1 and then force the plan. Class, do you want to force the plan 1? By clicking on yes, I can force this plan 1. Yes. I'm using graphical user interface here because I would like to show how the force plan work very easily. And once you force the plan, it will give a little tick mark over here, which represents that this particular plan ID 1 is currently being forced. So the next time you run the store procedure, no matter what parameter you use, right? We are using a different parameter here and then refresh. No new plan has been generated. And if you see here, if you execute by actual execution plan turn on, execute here, it is using the same forced plan, index seek and a key lookup. If you observe here, index seek and a key lookup is the one which we force the plan. That's how the forced plan work. So I wanted to place the query store in the read-only mode. So why I'm doing that? I am placing it in the read-only mode and I'm clearing out my procedure cache. I'm clearing out my procedure cache because I wanted to see the next time I run the store procedure, because there is no plan in the cache, it has to go ahead and generate a plan by looking into the forced plan, right? But I placed in the read-only mode. Will it go ahead and read that forced plan information? Let's go ahead and see. think I executed it. Clearing out my cache and then executing this store procedure, right? And seeing here if any new plan got generated. No new plan has got generated, and I would like to see the execution plan. If you see here, index seek and the key lookup is the same plan that got generated. And if you wanted to see in the plan itself, if it is using the force plan, you can find the use plan information here. Use plan is true, meaning it is using the force plan information. To turn the query store off, set the database set query store to be turned off. So if you put the database in the query store in the read only mode, it will still able to go ahead and read the force plan information and generate a plan, uh, the same plan as the force plan, and use that. Close this one. I would like to show how I used the query store to capture the baselines information, right? So we are using the wide world importers data warehouse database. I would like to use the same similar options and turn the query store to be turned on, the similar options that we did for the previous database. So let's say we upgraded this particular database to 2016 server, but then I would like to place, once we upgraded, still put the database in 2012 mode, so that I can go ahead and capture all the execution plan information, just like the way it used to run in older compatibility mode. Let's say we already have this store procedure, but just in case I'm creating it again, and then capturing clearing the query store and stock cache, executing the store procedure so that it will be captured within the database query store, wide world importers, query store, top resource consuming queries. I wanted to see in the grid view mode. Here, if you observe, there is this plan ID2 got generated. Okay. Now, let me go ahead and upgrade the database because we already captured this information in the query store. I will go ahead and upgrade the database now. Now, I do not know how this particular store procedure will work after I change the compatibility mode. Let's go ahead and see how it will behave, whether it will work better or worse. So if you see here, pretty cool, it worked fine. If you see here, you have to hover your mouse and see for the details. The total duration in milliseconds is 7.53. And you can also check all the other CPU time information, right? All the other, you can go ahead and check on all the other stats as well. So here, after the database being upgraded, it worked pretty fine. But what if there are certain queries that do not work fine and they do not run fine, right? You have the ability to go ahead and see what it used to run in the previous compatibility mode, so that it is very easy for you to go ahead and force the plan that you think is optimal. But here in my demo, it worked pretty fine, which is good. Let me close that. Let's see the third demo of so failures. Let's talk about the failures. So here, if you see the top resource consuming queries here, right? The previous one that got executed. We got two plans that got generated, but then if you see here, it is suggesting a non-clustered index here. So what if I go ahead and create that non-clustered index that is being suggested, right? Let me go ahead and clear out my query store before doing that. And then I'm going ahead and creating that non-clustered index that is being suggested. Now, if I refresh here, let me go ahead and execute this query, the store procedure. Now refresh. So it has created a plan ID 3. So it is using the index seek that you actually created, the non-clustered index is being used. So now to see how the failures work, we need to actually force this plan that is being used, right? That is using this index. So let me go ahead and force that plan. Now I force the plan. So what I will do is to create that failure environment. I will go ahead and drop the index that I have created. After being dropped, I'll run the query again. If you go ahead and refresh, if you observe here, the query itself doesn't fail. It gave the results, but then it created a new execution plan, plan ID force, even though plan ID 3 is being forced, right? But how do we know why is it creating new plan? Let me see what's going on. By using the queries with force plan, right? View queries with force plan. Here you see the force plan failure. There is a failure here. So what is the reason? No index is a reason because there is no index that is being used within the force plan. So that is the failure reason why it has chosen a different plan and created a new plan. Let me close this. Now I will go ahead and recreate the same exact index again and running the store procedure again. Now, will it cause any failures? If you see here, the plan forced failure count is still 1, and it is using the force plan. If you run by using the actual execution plan on and see the execution plan, it is using the index seek. And if you go ahead and see the properties, it is actually using the force plan. So if you create the exact same schema with same index, it do not have a problem to go ahead and use that force plan. Now, what if we modify the index a little bit by adding a column, dropping the index and then recreating it with a different schema? Now, if I go ahead and run the store procedure and then refresh the query store, forced plan failure count is 2. Now what happened this time, right? I changed the schema within the index. I added a new column. So even though you alter the index that is being used in the force plan, it will cause the failure. So there is no plan associated with that particular schema that is being used in the plan. We have changed it. So there is no plan associated with that new index. That is the reason. So again, the information is like, what is the failure reason? If you see here, it only says the failure count as 2, but you do not see the reason for the failure count 1. What is the reason for the failure count 1? So it always show the latest failure reason. If you want to capture all of the history of the failure reasons, right? You need to use the extended events. So I created a blog post in dbanuggets.com to see how you can go ahead and create the extended events to capture the failure information. Let's see, this is very interesting. So let's connect to the Azure SQL database and see how the automatic plan correction works. So it is automatically turned on, but I'm making sure it is turned on. And then I'm going ahead and check. I will go ahead and check whether the automatic plan correction is turned on. Select star from sys database automatic tuning options. We can check the status of it. I need to run in AdventureWorks database. So force last good plan is turned on, which is good. Now, let me go ahead and create this store procedure. the same stored procedure that we have been using on on-prem server AdventureWorks database. Let me clear out my query store just in case and the plan cache, and then create my workload. Again, in this demo, right, I'm not forcing anything. We will see how it will automatically force the plan itself by automatic tuning option. So we are in the AdventureWorks database, Azure SQL database. This is a query store, so it looks exactly the same. If you look here, all the options are the same. So I'm creating the workload, first workload, right? So let me go ahead and see top resourcing consuming queries. We executed just one query until now. So we have executed for 50 times. And let's see in the grid view mode, we have executed for 50 times, and that is the reason big circle, because execution count is big, right? Now we did not force anything. Let me go ahead and clear out my cache and then run my workload to cause the regression. So basically why it causes the regression is because these two are parameter sensitive. So it will go ahead and create a new plan for this particular query. So I executed that. Refresh. If you see here, we have executed only 10 times, and that is the reason a small circle. And if you hover your mouse over there, it taking 8,839 milliseconds, where the first plan is taking just around 1500 milliseconds. Now we have caused the regression, but in order for automatic plan correction to decide to force a plan, it needs to compare, and we need to run the previous workload again to make sure it compares the plans. So I'm running the previous workload, the same workload again 30 times to see how it will act now. Execute. Go to the query store, refresh. See, it is still executing, but it went ahead and compared and forced the plan ID 1. It automatically did that for us. That's how the automatic plan correction works. It will continuously monitor the regression between the execution plans, and it will force the last good plan. So if I wanted to know the reason why it caused the forced plan, by using this DMV, we can see the reason. So the latest reason is post last good plan is the average CPU time changed from 2 milliseconds to 733 milliseconds. So basically, it has to reach certain amount of CPU time for it to go ahead and decide to force a plan. So this is the reason. Again, you can see only the latest reason here. My last demo is query store hints here. So again, we are using AdventureWorks database, the Azure SQL database, creating the store procedure, the same exact store procedure, clearing out my query store and the cache. And here, this is the store procedure that we have been using in all of our demos. These are the two different parameter sensitive. So let's go ahead and execute and see their execution plans. I need to run in database. Oh, it's running in local server. I need to connect to the AdventureWorks all over again. I will do it all over again. Okay. Now let me go ahead and execute this, right? And see the execution plan. So if you see the results, the first execution created like produced 360K rows, but the second execution just gave 385 rows. But if you see the execution plan, as you executed for the first time, I do not know why it has created this index seek. That's interesting. It should go ahead and create the same one because we did not force a plan, because this is the first time it created the clustered index. So it should create the same clustered index. I don't know what's going on with this. Let me clear out. And then let's see. Top resource consuming queries. It should clear out everything. Nothing is in there. Okay. So let me go ahead and execute this. Let's see if there is nothing in the plan cache. So let me execute that. It's still using that index seek, but it should create the same execution plan because this is the one it created for the first time. But then let's see here. So basically, how to use the query store hints. We need to capture the query text of this particular store procedure. So by using this catalog views, we can find out the query ID. I don't know what's going on here. Should give me my demos are breaking today. I don't know why. Let's see what's the query ID for this one. Refresh. Am I running on the I executed, right? Okay. I have no idea. It should show me query ID. It should show me the ID by using this. Let's see. So did I turn it on? Did I turn the query store on? It's showing here. I don't know why this is breaking. I'm sorry. My demo is acting very weird today. Oh man. Okay. Clear out. We are still in Adventure Works database. We have only 3 minutes. I don't want to rush on your time. Execution plan. Now, if you observe, now it is working fine. So the first execution, it created this plan. So even though 385 rows, it created the same execution plan. But for 385 rows, we do not have to do the clustered index scan, right? So let me go ahead and find out the text query ID. Now it will work. I don't know why it didn't work previously. So query ID 1 for this particular store procedure. So by using the query ID, by using this particular store procedure, set hints, by using the option recompile, if I execute that, it will go ahead and sense the parameters the next time, and it will go ahead and create the execution plans based upon the parameter value. So if you observe the next time it executes, if you observe here, for this particular one, 360K records, it choose an index scan, clustered index scan. And for this 385 rows, it choose index seek and the key lookup. So it is actually recompiling, right? But what are my query store options here? Hint options. So the option recompile for the query ID 1 is the query hint ID 1. But what if I go ahead and do a update on it? I wanted to right now use the max.1. 1. So the query ID 1, I'm updating it to max.1. And then I would like to go ahead and run again to see the execution plans. Right now we updated it, right? So it is using clustered index scan on both of them again. But then if you see the properties, it is using the max.op set to 1. But then you can also use the multiple hints here, like recompile as well as max.1 together. So if you execute again, the next time it runs, right, it updates both of them, recompile and max.1. If you see here, it has actually recompiled and also using the max.1. So what are the query, if you wanted to clear out the query hints, right? So we have updated on the top of each other. So what are my query store hints right now? If you see here, it shows the latest one. It do not show the history of the query hints, but then it will give the hint ID, like we have updated it 3 times. So the third one, the latest one is this. Now, what if I go ahead and clear out everything? So I cleared out. If you see the query store hints, nothing will show up because we cleared out everything. That's how we can clear it out. To know the list of the query hints that can be used, this is the article. You can go ahead and see what all query hints you can use. Let me go back into my slides. Kevin, do we have a little bit of time? Can we take some time to go through the takeaways?
Sure. Say 10 minutes.
Sure. Yeah, it will be done in 10 minutes.
Perfect. Let's go for it.
Yeah, thank you, Kevin. So we have seen the demo. We have seen how the query store actually works, options, and the query store hints everything. So as an overview, let's go through the takeaways of what we have learned today and couple of the new things also mentioned here. So we cannot disable the query store on Azure SQL database, single database, and on Elastic Pool. There are certain trace flags that you can enable. So basically, let's say you enable the query store, right? And then you wanted to you wanted to restart the SQL Server. So before restarting the SQL Server, all the data that has been captured in the memory for the query store will have to flush out to disk, and then it will restart the SQL Server. So it might take some time if you do not want that, if you want the SQL Server to restart pretty quickly, but then you do not want to bother if you lose the data that has been captured during that time to be lost. If you do not have that worry, you can go ahead and enable the trace flag 7745 to avoid writing the query store data to disk before SQL Server shutdown. There is also other trace flag which is enabled by default in SQL Server 2019. But if you are before SQL Server 2019, think about enabling the trace flag 7752, which will enable the asynchronous load of query store. So let's say you restart the database or you restart the SQL Server, and if you have the query store data in there, right, you already enabled the query store on the database. So once you start the database, it might take some time until the query store system information load into the memory. It might take some time to make the database available and online. So it will take some time to load that information into the memory and then come online. But if you do not want that, you can make sure that the query store information is being loaded into the memory asynchronously after starting the database, after it being enabled. You can do that by enabling this trace flag. But then while the data is being loaded into the memory after your database coming online, during that loading phase, right, your query store will be in the read-only mode. And that is by default turned on in SQL Server 2019. For the native compiled queries, query store doesn't capture, but if you want to make sure that information will be captured, you need to enable sys sp xtp control query execution stats. And if you have lot of ad hoc queries, it is advisable to use optimize for ad hoc workloads option to save the cache memory. And also you have a specific query in the Microsoft Docs to go ahead and clear out and clean up all the ad hoc queries captured in the query store. If you do not want those, go ahead and run that query. It will go ahead and clear up ad hoc queries from the query store. And the maximum plans per query is set to 200 execution plans by default, but you can go ahead and change that. Usually based upon your workload, right? Sometimes you need it, sometimes you do not have to do that. So you can just go ahead and change that. And if you do not put the size-based cleanup mode to auto, and if it is turned off, it is by default in the auto mode, but please do not turn it off, because if your maximum storage size is reached, Query Store will go to the read-only mode. Now, if you place in the auto mode, like we discussed, once the size limit reaches 90%, it will go ahead and delete the old data until it reaches the 80%. And auto mode will actually avoid the ad hoc queries with small resource consumption if you are in the auto mode. Again, that is by default from, I believe, 2017 and above. But if you are in the 2016 mode, please go ahead and change that to auto mode based on your workloads. And Query Store capture mode, like I said, it is recommended, and it is by default auto mode on Azure SQL Database and SQL Server 2019. Not the 2017, but 2019. Once you enable the Query Store, you will need so many catalog views to go ahead and query them to grab the information that you need. QDS Toolbox is designed by Channel Advisor, which is freely available in GitHub repo. Go ahead and look out. Those queries are really helpful. And if you have any questions, right, for every single session I give on Query Store, they have this question: will that cause the performance overload? So if you have that question, Erin Stilato have this wonderful blog post where you can go ahead and look into. You'll get all the answers from that blog post. To learn more about the best practices, Microsoft Talks, they have that link. And also you can look into my blog post, dbanuggets.com, to get those extended session of today's session. If you want to learn more, you can go ahead and look into the blog post. And then these are the resources that I followed to prepare this presentation. And the pictures that I used are from pixels.com, which are completely free, and you can go ahead and use it. Thank you so much, Kevin, Steve, and Sean, for giving me this wonderful opportunity to present for your user group.
Oh, my pleasure. Definitely our pleasure to get all that done. We learned a lot about Query Store today. I do not see any questions about Query Store, but I do have one question myself that's been on my head, at least for a while anyway. Is there any reason why someone would not use Query Store?
Is there any reason why someone not use Query Store? Because if they do not choose it, they might be worried about the overhead. But Query Store from Microsoft, they have added many features lately to solve those performance overload problem. Again, the blog post that I mentioned, right, from the SQLskills.com by Erin Stilato, please go ahead and read that. But I do not know of any reason why they do not choose Query Store for any specific reasons other than that.
Perfect. Because everybody's been pushing Query Store for some time, and hopefully everyone today has learned something new about Query Store and why they should be using it. I wanted to make sure there was truly no reason not to.
And that is one of the top features in 2022 coming up, SQL Server.
Cannot wait.
Yeah, me too.
All right. So with that, I do thank you. Hopefully y'all learned something about Query Store. So hopefully y'all will come back and join us next time with our next presentation of VBA fundamentals. Yes, you have a question?
Kevin, how many attendees did we have today? Will you send me the list, or will you send me the count?
I'll send you the count.
Thank you so much. Appreciate it.
Perfect. Yes. Next week, we will actually be meeting. It's going to be Steve Jones talking about encryption. So with that, hopefully y'all will join us next week, and we'll talk to y'all then. Thanks, everyone.
Thank you.
Have a
Bye-bye.
great day.
Thanks for joining. Bye.
Bye.